So this is a little complex topology on our network. Maybe two PC is not connected with the other because of the long distance. So we can use the switch to connect with each other. And there are some other problems in our network because we see about the switch, how to learn and how to follow the traffic. This is automatically finished by the switch. And in a little complex more scenario, let's see, like this one. Now our company not only have one department of the IT department, we still have a new finance department. And our requirement is if the broadcast from IT department, this packet can be flagged to all the terminal, also belong to the IT department, but the finance department cannot receive the packet. So this is our requirement. How to meet this problem? How to meet this requirement? Who can give me some solution? If there is a new requirement, how to solve this problem? We want to stop the broadcast. Okay, I see the correct answer, VLAN. Or maybe do you already know my material before? Yes, this is our next technology about VLAN. So what is VLAN? Why we use the VLAN? Let's see this topology. We have multiple terminal, right? Some terminal belong to IT and some terminal maybe belong to the finance. So if we want to limit the broadcast domain, for example, when PC send out the broadcast packets, and we hope only the blue one, that means the IT department, will receive the message. How to limit the scope of broadcast? And actually, if switch can know this requirement, what's mean? For example, here is a switch. We connect with 4 terminals, right? And later, if now the terminal send out the packets, and I will tell the switch, this packet belongs to my IT department. You have to forward the traffic also to the destination belong to the same IT department. And the right terminal also will send the packet, carry the finance information. So if switch receives this information, and I also can recognize the packets, maybe finally I only will send the packets to the IT department, not to another department. But about the switch, they cannot know what means IT, what means finance, but I know the number, right? Maybe I will give the number for IT department and I will give another number for finance. So this number we call is VLAN, right? For example, I assign the VLAN 10 for IT department, and I will later send out the packets carry the VLAN information. The switch forwards the packet not only according to the MAC address, but I also will check the VLAN information. Yes, I will send the packets to the same VLAN. So this VLAN target, the VLAN tag is similar function like we want to add the IT or add the finance. So this is a function of VLAN. And about the right one, we will assign the VLAN for VLAN 20. So maybe the ether frame send out the packets will carry the VLAN 20 information. So the switch for the traffic, we see not only according to the MAC address information, we also have to check the VLAN. Yes. And later, let's see what's the information on the VLAN. Because as we know, maybe we only add the 10, and then switch will forward according to the 10. Then the other packets carries the VLAN 20, and I will forward according to the 20. So what's the detail about the VLAN? 10 and 20, as we know, because everyone could maybe create a VLAN as before, and then what's know the function of the number. But actually in the real network about the VLAN, not only about the 10 and 20, we still have some other information on the VLAN tag. If we use the VLAN on our network, this protocol we call is AO2.1Q. Pay attention about this protocol. AO2.1Q, because maybe when you do the configuration of the AP, you also see the parameter is AO2.1Q. That means you already add some information of the VLAN. So this is AO2.1Q. If we add the VLAN, this packet we call is AO2.1Q packet. Otherwise, we call the Ethernet frame is a stand frame. And let's see the information. We add the tag to the standard Ethernet frame header, and here's some information like this. Pay attention. By the standard Ethernet frame, we will have the destination MAC address, source MAC address, right? And the type, length, date frame. Date frame means the layer 3 and the upper information. And we have some track information on the FCS. This is a standard package. If we add the tag, that means we will add this part information in the layer 2. So the VLAN also belongs to the layer 2 part. And what's the information of the tag? Let's see. We have two parts. The first one we call it TPID, Tag Protocol Identifier. This is a fixed value. The value is 8100. That means when switch receives the packet and I see the value is 8100, I have to forward the packet according to the VLAN information. So this is a fixed value. And the second part is a TCI, Tag Control Information. And this also has three parts. The first one is a VLAN ID. It has 12 bits long, indicates the ID information. Because the length is 12, so the range is from 0 to 4095. This is the range, but the available range is from 1 to 4094. So this is available. So maybe when you create the VLAN, or maybe in the future you do the practice, pay attention, you can try to create a VLAN 100, it's successfully. You can create a VLAN 2000, it's successfully. But if you want to create a VLAN 5000, it cannot work, right? Because we have the limit. That's why you can create successfully or not successfully. Of course, in some different switch, we also have the limit of VLAN number. For example, totally, maybe you only can create 16 VLANs or maybe 20 VLANs, depends on your real device. But the available range is from 1 to 4094. So this is the first part. And the second part is about the priority. It has 3 bits long. So the range is from 0 to 7. Maybe in your network, you have different priority traffic, like the voice, maybe like the date. And if the resources, the bandwidth is not enough, we hope the voice can be forwarded as soon as possible. So we can give different date, different priority. And this is a part of the VLAN, the second one. The third one is the CFI. This one have 1 bit long, and we know this part is enough. We have to focus on the VLAN ID and the priority. Okay, so this is a standard one. And then let's see the process. For example, in this topology, we have multiple terminal, right? PCA, PCB to PCN, multiple devices. And we divide the different terminal into different departments. Maybe VLAN 10 for IT, VLAN 20 for finance. And later, when the switch receives the packets, at the beginning, if we don't have the VLAN, the MAC address table will only have the MAC address information and the interface information. But later, if we use a VLAN, PCA send out the standard Ethernet frame. That means we don't carry the VLAN information. And later, the switch will add the VLAN information. Because about the switch, we have to do the configuration about the VLAN. Pay attention about this one. We see the switch for the traffic according to the MAC address information, and the switch learn MAC address and makes the MAC address table automatically. We don't need to do any configuration. But if we want to use a VLAN, we have to add the configuration. For example, like this topology, I add the port 1 to VLAN 10, port 2 to VLAN 20, port 3 to VLAN 10. And when my first interface, port 1, receives the standard Ethernet frame, later I will add the VLAN 10 about the standard frame because we already added the configuration here, right? And later, after we add the VLAN information about the 10, if this is a broadcast, finally, the packets only can be sent out on interface 3 and interface N because we add this interface into VLAN 10. That means VLAN 20 about the interface 2 and the other interface cannot be forwarded to the interface because this interface belongs to VLAN 20. So in this scenario, the switch for the traffic not only according to the MAC address, but also focus on the VLAN. So this is the information of the VLAN. About the switch, if only can deal with one VLAN, what means deal with? Deal with means I receive a standard Ethernet frame. Without VLAN, later we will add the VLAN information. And then for the traffic out, according to the VLAN information, if the VLAN is same with the other interface, I will delete VLAN. So this is the action we call is deal with VLAN. If one interface only can deal with one VLAN, this interface we call is access type. It's clear for you? Yes? So this is the first one of the access. So in this scenario, if we have two types of VLAN, VLAN 10 and VLAN 20, and we use the access VLAN, it's enough for you, right? Because different devices, we can use the different VLAN and to limit the broadcast. But pay attention. In our real network, it's impossible. All the terminal to connect with one switch is enough. Maybe between between two terminals, we have multiple switch, right? So the typical scenario is like this. PC1 and PC3 within VLAN 10, PC2 and PC4 in VLAN 20, and between them we have multiple switch. So there is a question. If we only have access VLAN, it's enough to forward the traffic within the same VLAN or not? The access interface is enough or not? Let's see the process. If PC1 send out the standard Ethernet frame, and the switch 1 will add the VLAN, right? And this VLAN should be VLAN 10. It's okay? And this packet cannot be sent out of interface 2 because interface 2 we connect with VLAN 20, right? So maybe this interface can be sent out of interface 20. If interface 20 can send out the packets and then delete the VLAN, that means the VLAN 20 have to belong to the interface 20 have to belong to VLAN 10 at the same time, right? Then the packets will be sent out and delete the VLAN. But if at this time, PC2 also want to communicate with PC4, the packets will send to switch 1, switch 1 will add to VLAN 20, right? The interface 1 cannot be sent out because the interface 1 belongs to VLAN 10. At this time, the interface 20 also cannot forward the traffic of PC2 because this interface will already assign the VLAN for VLAN 10. That means at this time, PC1 and PC3 can communicate with each other, but PC2 and PC4 cannot. If we assign the VLAN for interface 20 to become VLAN 20, that means 2 and 4 can communicate with each other, but 1 and 3 cannot. So how to solve this problem? In this scenario, the interface 20 have to carry multiple VLAN information, right? So we have to use another type. This type we call is chunk. Yes. A trunk interface means we can allow multiple VLANs to pass through, and the frame will send out carries the VLAN information. When switch 2 receives this information, I will assign the packets according to the VLAN tag. So this is the function of the trunk. Yes, carries the VLAN 10 and also carries the VLAN 20 to the destination of the switch 2 and finally to forward the traffic. So this is a function of the trunk. And finally, when switch 2 receives the packets, I will delete the VLAN 10 and send the packets to interface 1. And 1 and 3 can communicate with each other. The same process, PC2 and PC4 can communicate with each other too. So this is the principle of the access and the trunk. That's why we say the trunk interface always may be used between different switches because maybe multiple VLAN have to be forwarded within one cable. But about the access interface, you only connect with the terminal because terminal cannot recognize the VLAN. So this is a trunk. And how to finish the configuration? If you want to use the VLAN to communicate with each other, if there is a topology, 1 switch and 2 terminals, how to finish the configuration? We have 4 steps. The first one, we have to create the VLAN. And the second one, we have to configure the interface. Also set up the VLAN type. Maybe it's access, maybe it's trunk, and also to assign the VLAN for interface. And finally, we have to check the VLAN state. So there are 4 main steps of the VLAN configuration. And later, let's see how to create the VLAN. The command is here, switch and VLAN, and then to give a VLAN number. Pay attention. If you only have the training and don't do any practice about the command, you will forget as soon as possible. So I only explain the main command of the configuration, and after the training or maybe in your work, you have to do practice maybe every day, maybe every 2 days. Otherwise, you will forget the command very quickly. So I only explain the main command for you. This is the command to create the VLAN. In the second step, you can give the name. Of course, this is the optional configuration. That means if you don't use this command, the VLAN also can work. But this one is help us to understand our network better. For example, VLAN 10 for IT department. And this is example. We create the VLAN 10 and give the name is IT. VLAN 20, the name is finance. And the second one, we have to create the access interface. Usually, this interface is used to connect with the terminal. To enter the port, enter the interface, and then to switch the mode to be accessed. And the third step, we have to add the port to specify the VLAN. Okay, so this one also is very important. That's why on the example, we say the first interface is used to connect with VLAN 10 because this interface we are ready to give the special VLAN. This is a command. Interface, this is the multiple interface. We will add this command in 2 interfaces. The first one is F01 and the second one is F02. Both of 2 interfaces which change the mode to become access and give the special VLAN for VLAN 10. Pay attention. About this example, we skip the step 2, right? We don't change the access port because about the switch, default mode is access mode. So we can directly to give the VLAN for the interface. About the interface 3, to switch the VLAN to become 20. So this is the configuration of access. The second one, how to finish the configuration of the trunk. We have to also enter the interface and to change the mode to become trunk. This is the same of the access interface. And then we have to define the VLAN control behavior. And for example, to allow which VLAN pass or maybe this do not allow the VLAN pass, something like this. This is action. Allow the VLAN or maybe we direct it to remove the VLAN. This is a very important configuration. We can change the trunk native VLAN. By default, the native VLAN is VLAN 1. So here is an example. We can enter the interface and change the mode to become trunk, and later enter the interface to remove the VLAN 1 to 24, 40, and 94. That means at this configuration, this interface not allow anything of the VLAN. And then we can add which VLAN can be passed through. So this is a command switch port trunk, allow the VLAN, and we add the VLAN 10 and 20. So that means about the interface 2, we allow the VLAN 10 and 20 and can pass through. If we don't change the native VLAN, the native VLAN is VLAN 1. So this is a typical configuration. And later we can use the command. For example, if now you create the VLAN but the VLAN is not used, you can direct it to delete. The command is no VLAN and then to give the VLAN ID. And we can use the show VLAN to check the VLAN information. Show VLAN, for example, like this. Show VLAN in our system, we have VLAN 1, VLAN 10, and VLAN 20. And the state is static. That means we create the VLAN manually. And which interface can allow this VLAN pass through? Pay attention, by default, only VLAN 1 exists on our switch, and VLAN 1 cannot be deleted. Pay attention. Yes, do not in your live network. Yes, this command can be used on the switch. Okay, so this is the basic configuration. And here is a summary of the VLAN. What's the purpose of the VLAN? VLAN are used to control the unnecessary broadcast domain. That means we want to limit the broadcast domain, and only within the same department can send out the broadcast packets out. Otherwise, we cannot receive this information. In this scenario, we can use the VLAN to control each other. But about the interface, how to deal with the message? I have a brief summary for you. Besides on the port type, access, and the trunk, we have two directions. The first one receives the message. The second one sends out the packets. For example, if here is the switch and we receive the packets from this interface and want to send out the packets of this interface. If we receive the message without the tag, maybe the packet is sent out from the terminal. About the access and the trunk, if we receive the packets without tag, we will add the native tag. If we receive the packets with tag, that means maybe I receive this interface and the other side is switch. We will compare the VLAN ID. If the VLAN ID is same with the native VLAN, the packet will be received. Otherwise, the packets will be discarded. This is the action for access. About the trunk, if the native VLAN is same with the packet VLAN, I will receive. If the VLAN ID is different, I will check the permission list. If the permission allows the packets, we will receive. Otherwise, we will discard. This is the site when we receive the packets. But if we want to send out the packets of the switch, we also will check the port information. When we use the access interface, I will remove the tag and send the packets out. If we use the trunk, we will compare the VLAN ID. If VLAN ID is same with the native VLAN, we will remove the VLAN and then to send out the packet. If the VLAN ID is different, I will keep the tag and send out the packet. Of course, this VLAN should be located on the permission list. So here is the VLAN information. About this part, any question? VLAN is very important because not only used on the switch, maybe when we use on the wireless network, we also create the VLAN for the AP, maybe for the wireless controller. So VLAN is very important.